All right, question 4. It says compute SR to the 15th and express the result in cycle notation. All right. Now, again, this requires some knowledge of dihedral groups. We know SR to the 15th. SR is a reflection or flip. So that tells me what? That tells me that SR squared is equal to the identity. So that means I can break this down into squares times what's left over. So I can write this as SR, well, let's write it as SR to the 14th times SR. Now SR to the 14th is just SR squared. I'm sorry, SR squared to the 7th power times SR. But that's equal to ID to the 7th power times SR, which is SR. Okay. So the answer is SR. And if you want SR in cycle notation, we can just, we know S is going to be the flip that leaves A fixed. So just to remind yourself, the flip that leaves A fixed is going to be BF times CE. That's an F, sorry. And then that's going to be times ABC DEF. And we know this result is a flip, so this is the flip that takes A to F. And the flip that takes A to F is also going to take B to E and C to D. Okay, so that's the result for part A. All right, so that's for A. Now, for part B, I want SR squared, and then SR to the 8th. Okay. All right, now, first thing you want to do, once you notice a power bigger than 6, you want to reduce that. All right. So that's going to be SR squared, well, I can write this as R squared R to the 6th, but R to the 6th is the identity, so it's equal to SR squared. Now at this point, if you did that, you could notice, there's several ways to do this. You could notice that this is equal to SR times SR squared. But SR squared is a flip or reflection, so that means that the SR squared is going to be the identity. So I just get SR again. All right, so that's equal in cycle notation to AF, BE, and CD. Okay. Now, another way you could do this is use the relation SR to the M equals R to the 6 minus M. Sorry. And you can use this relation to flip your S's around. For example, that means that SR squared, SR squared. Let's see. Suppose I want to flip this R and this, exchange this R and this S. Well, SR squared is equal to R to the 4th S. So I could write this as SR times SR squared, and then what's in parentheses here becomes R to the 4th S. Now look at what happens here. Then I get a whole bunch of collapsing. SR times SR squared. I could put the R squared and the R to the 4th next to each other. So that's the identity. So then I get SR times S times the identity times S, and that's SR times S squared, and S squared is also a flip, so that's equal to SR. So I get the same answer either way. Right? So the important thing here is be able to use algebraic relations on these symmetries, or to notice that what you have here is a flip, so flips around, and I'm sorry, so what you have here is a flip, and if you square a flip, you get the identity. So that's how you do that.